Okay, today we're looking at the notes on how to graph systems of linear inequalities. So first, when we're graphing systems of linear inequalities, we want everything to get into slope-intercept form. So that way we can graph each equation. And then when we're solving inequalities, remember, we have to flip the sign whenever we multiply or divide by a negative number. And graph all the inequalities on the same coordinate plane. Remember, solid lines are the less than equal to greater than equal to. Dashed lines are the less than and greater than. Less than we shade down, greater than we shade up. So this first one, which I'm going to graph with this green color, is y is greater than -4. So I go here to -4. I want all the y values above it. I could plug this into Desmos. To graph this in Desmos, I would write y equals -4. That's going to be my green line. And it looks something like this. It's dashed because it is strictly greater than. The second equation, y equals -x minus 1. It looks like this. Here's -1. Up 1, down 1 over 1, down 1 over 1. And because this is an equal to, that means it's a solid line. So I'm going to go ahead and draw my solid line. Now here you have a couple options. I'm going to use a pencil. Yes, I colored in different colors, and you can use these different colors to shade. I'm going to use a pencil to show you another way that I can shade. So I'm going to start first with this one. This is y is greater than -4. So I'm going to put my pencil right here on -4, and I want all the y values above that. So I'm going to draw vertical lines going up. Everything above this green line. The next one is y is less than or equal to this. So I'm going to put my pencil right here, and I want all the y values below it. So if I'm going to go ahead and notice as I draw my line here, that means all of these, I'm going to actually shade it this way. I want all the y values below this. And what I've noticed is the area where both of the shading happens is right here. This satisfies both inequalities. When you look at problem number two kind of sets up like that. Problem number 2 says any ordered pair that makes all the inequalities true and is where the shading overlaps the graph. Okay, so that's our solutions. So we want all the y values above. I'm actually going to do this in purple. All the y values above -2x plus 2. -2x plus 2 is this line right here. So I want all the y values above it. I'm going to draw a little arrow that's going up. And in this one, y is greater than 1/2 x minus 4. Here's x minus 4. I want all the y values above it. So the place where they are both above both lines is here at B. So the region that contains my solution is B. Prove algebraically that 3, 0 works. Here's what it means by prove algebraically. It means put it into the equation. So my first equation is y is greater than -2x plus 2. This is my x value. This is my y value. So y, which is 0, is greater than negative 2 times 3 plus 2. Negative 2 times 3 is negative 6. Negative 6 plus 2 is negative 4. And yes, 0 is greater than negative 4. So it works for that first equation. Now for my second equation, y is greater than or equal to 1/2 x minus 4. I substitute the 0 and the 3 in. 0 for the y is greater than or equal to 1/2 3 minus 4. Half of 3 is 1.5. So 0 is greater than or equal to 1.5 minus 4. So 0 is greater than or equal to negative 2.5, which is also true. So it works for both of those equations. So B is the correct area. Number 4 and 5 are practice. So I want you to go through, graph these. Yes, you're going to have to solve on this one. And yes, this you can just type into Desmos, x equals negative 3, y equals 2/3 x minus 3. Graph and shade in Desmos. The one I want to cover is number 6, the special case. So first, here this is y is less than x minus 2. So I'm going to change this less than to an equal to, so that way I can graph it. X minus 2, that's right here, is negative 2 is my y-intercept. My slope is 1, and it goes up like this. And it is less than, so this is a dashed line. And I'm going to want all the y values below that because it's less than. This next one, y is greater than instead of greater than or equal to. I'm going to write equal to so I can graph it in Desmos. When I graph it in Desmos, I get my points. My y-intercept is 1. My slope is 1. So it goes like this. This is actually greater than or equal to, so this is a solid line that goes this way. And I want all the y values above. So I want all the y values above the purple line and below the red line. And what I notice is these two have the same slope. They are shading in opposite directions. There are no solutions here. So that's the special case. I expect you to practice on problems 4 and 5, graph them in Desmos, and then shade properly.